In this video, we're going to look at hypothesis testing using the binomial distribution again, except this time we're going to look at two-tailed tests, single-tailed tests where we're looking for the probability being higher than stated, and also we're going to look at critical regions. So, first things first, what's the context behind this model? In this model, we're looking to see whether the number of rainy days in April has increased. So, if we look at this, there are 30 days in April, so that's 30 trials. We're assuming independence, so that we can use a binomial distribution. In fact, if one day is rainy, it may be that it's more likely the following day will be raining as well. But that's an assumption that we're going to make. We could state that as an assumption in the question. So, 30 days in April, and historical records show that there's a 30% chance that any day in April rains. That's the model that we're using. So our null hypothesis is that this model is still the same, i.e. that the probability is 0.3. Obviously, the number of days in April will stay the same, so that's the only bit of the model which could be wrong. Our alternative hypothesis, because we think the number of rainy days has increased, we're going to look at the probability is greater than 0.3. Now, if we were to perform this test properly, we would make our prediction, and then we would look to collect evidence this coming April to test whether our claim is true or not. So, what work can we do whilst we're waiting for April to roll round? Well, what we can do is we can look at our model here, and we can say, well, if we're going to use a 5% significance level again, how many rainy days would there have to be for us to reach that critical value, that first value, which means that we are inside our significance level? So remember, we're looking for the probability being greater than that stated this time. So there will be some model that looks something like this. Try and keep them all the same width, they should all be one wide. And we want to know what probability of being, let's say, we're not sure, but we could probably guess. Let's say, so we're expecting 9 rainy days, so maybe 12 rainy days would be too many. 12 or more, is that in our critical region? Okay, so that's the idea that we're aiming for, and we need to find out what that number is. That means there's only a 5% chance of there being that many days or more in which it rains in April. So we've got our probability here and there. And now what we're going to do is we're going to say, so the probability that x is greater than or equal to a value. Now we're going to have to guess at some values here if you're using your calculator, or if you have the statistical table, you can use the statistical tables, but let's use the calculator that you've got for now. So we would have a guess. Let's say we thought, well, we're expecting 9 days, so maybe 12, 13, 14, some number around there would be sensible. So let's just try some of those numbers. So what you'll have to do is put your calculator into list mode, and then just enter roughly the values that you thought might be near that critical region. That's small, but reasonably likely to happen chance. I'd probably go for 12, 13, 14 if we're expecting around 9. So, putting those in my calculator, what I would need to do is look in list mode, and I've tried 12, 13, 14. I want to write the two which are closest to 95%. Okay? Just remember though that your calculator only tells you the probability that you're less than or equal to a number. So we're actually going to be calculating less than or equal to, say, 12 in this case. So our first number is going to give us this area here. So if I put 12 in, that's going to give me 0.9155. And then if I input 12, if I then input 13, I get 0.9 0.599. Okay, so what has that told me? Looking at my diagram, that's told me that the probability of being 12 or less, this area downwards, is 0.9155. And that the probability of being 13 or more, or less, sorry, is 0.9599. Remember, I was looking for a 5% significance level. So straight away I realise, these are both 90-something percents. I need to do 1 minus these numbers so that I can compare them to the 5% that I was after, and hence I also need to do 1 minus those probabilities. So if I'm looking for this, that's going to give me 5, 4, 8, 0. A 0.0845 chance. This one gives me 1, 0, 4, 0, 0. A 4% chance. Unless the question states otherwise, I should always go for the one which is below my significance level. Occasionally they'll ask you for the closest. In this case, it doesn't matter. This is less than 5%, so I will accept this one. Only thing I need to be careful of is that if we look at this, I've actually done 1 minus the probability that x is less than or equal to 14. So looking at my sketch, I have taken away all of this area from 13 downwards. So what's my first number that I have been left with? Well, that is going to equal the probability that x is greater than or equal to 14. So notice, I put 13 in the calculator, but that was the probability that I was up to and including 13. So I had to do 1 minus that to get the 5% number that I was interested in. As I did 1 minus the probability of everything up to 13, I will be left with the probability of 14 and greater. So therefore, it's the probability of 14 or greater, which falls into my 5% significance level. Therefore, my critical region, that region which will cause me to reject my H0 and accept my H1, is any value of x which is greater than or equal to 14. That means come April, when I count the number of days with rain, if I get 14 or more days with rain in April, I know that my hypothesis is wrong. The probability should be higher than 0.3. Okay? That's how we can test the upper tail.